Okay, we're going to take a look at what to do when you have a quadratic factor. Essentially, for partial fraction decomposition, this applies to whenever you have a factor that you cannot factor and you end up with it being quadratic. In the last example, we looked at x squared minus 9. That was quadratic, but it was factorable. So when you have this situation where you have a non-factorable quadratic factor, you have to replace that quadratic factor every one of those you're going to replace it with, I think we're using purple, with ax plus b over the quadratic factor of ax squared plus bx plus c. And that's what we're going to do here, where we have to find the constants a and b. So every quadratic factor gets replaced with this partial fraction decomposition. So you have now 1 over x, that's linear by the way, x squared plus 25. So you have a linear factor with the x, and the quadratic factor over here. So for the linear factor, this will be a over x. Now for the quadratic factor, down here the x squared plus 25, we're going to use bx plus c because a is already chosen. A is already selected. So we'll find the constant a, constant b, and the constant c. So you might want to take a look at all the factors here. And again, we're going to use our algorithm whenever we add or subtract fractions with what we say unlike denominators, different denominators. We already shared with you guys this addition subtraction algorithm. So we end up with AD plus BC over BD. So multiply diagonally across and then horizontally across for your new denominator, and here we go. So we have this algorithm for the arithmetic. Okay. So we end up with a times x squared plus 25 plus x times bx plus c. This is all over the x times x squared plus 25. Okay. So again, what we use here is a couple of things. Let's remember, we're going to use some logic again, that if you have a fraction, a over c equal to b over c, then that means a is b. What we're saying here is, if your denominator is both c here, and these fractions are equal, then the numerators are the same. So we're using that same logic that we've done for the other cases. So we can see they have the same denominator, and that means our numerators must be the same. So that we get 1 equal to a x squared plus 25 plus x bx plus c. So our numerators are the same. All right. Okay, so we have this equation now, but the problem is we cannot zero out any terms. I might be able to take some cases just to start. There's a few things I think that we can do. You might start by saying, what happens if we let x be 0? Well, we'll get a 0 over here. And then I get 1 is 25a. Or a will be 1 over 25. So I did get one of the values I need, which is a. I need b, and I also need c. So we can start by just simply looking at cases here. I also want to point out to you another thing we can try. Since x was pretty good, we could look at another value of x. I might even say, let x be 1. Let's see what happens. We need another page. So if we said, let's let x now be the value 1, we'll end up with 1 equals a 1 squared plus 25 plus 1 b times 1 plus c. A, and I guess that'll give us a nice 26a plus b plus c. And so you notice now a can be replaced with 1 over 25. So we end up with 1 being 26 over 25 plus b plus c, or we can say b plus c is 1 minus 26 over 25. We can replace this with 25 over 25, and then we get the equation that b plus c will equal negative 1 over 25. Now, let me just highlight this here. So if we go back to the same equation now, and pick another value of x, like maybe -1. I can plug in now -1 wherever there's an x, and we could get another equation in terms of b and c. So this time, looking at the case when x is -1, we obtain 1 equals a times -1 squared plus 25 minus b times -1 plus c. So I get a times 26 minus -b plus c, 26a plus b minus c. So let's recall that a is the value (1 over 25). So we can substitute that value back in. Now we get 1 equals 26 over 25 plus b minus c. Or we can say, if we get some more paper here, b minus c is 1 minus 26 over 25. We're going to replace the number 1 with 25 over 25. And then now we get b minus c is -1 over 25. Okay. So we also know b plus c is -1 over 25. So we have two equations and two unknowns. Let's use that. B plus c is -1 over 25, and b minus c is also -1 over 25. So we're going to use the addition method. Well, we got a system of two equations and two unknowns. We could use this fact if you guys want to remember from beginning algebra, right? If I got one equation equal to another, and one equation and two equations, I can add the left sides together, and that's equal to the sum of the right sides. So this is really the addition method from, I should say, beginning algebra. You study this when you solve a system. So on the left, you end up getting 2b because you're adding the left side and the right side. So you're going to add these together plus these. And you get 2b is really -2 over 25. So I can solve for b now by dividing both sides by 2. And I get b is -2 over 25 divided by 2. -2 over 25 times 1/2. And your b will be -1 over what? 25. There we go. So we have A, we have B. Okay. we could use any one of these equations now to get c. So if I start by using that first equation, doesn't matter which one, but we can do that. Copy. We're going to replace the value of b over here with the negative 1 over 25. So that negative 1 over 25 plus c is negative 1 over 25, or c will be negative 1 over 25 plus 1 over 25. This means c is the value 0. So I think I'd rather just highlight the numbers. And we know a is 1 over 25. B is negative 1 over 25, and c is 0. So let's fill in the values. So I'm going to put my answer here. I'm going to erase this. Now let's put this all together. 1 over x squared plus 25 will equal 1 over 25x minus 25 down here, x squared plus 25. And you say, is that a 1x or just an x? You could just put the x. And it does mean 1x. Okay. Here's another example. You got a linear factor. X squared plus 9 is not factorable, so you have a quadratic factor. All right, so 18 over x plus 3, the linear factor, but now you have a quadratic factor. So this will equal a over the linear factor x plus 3. Now we're going to have the quadratic factor, x squared plus 9. Again, we write this as bx plus c. And that quadratic factor, notice, is not factorable. X squared plus 9, not factorable. All right. Using our addition algorithm for fractions, you get a x squared plus 9 plus x plus 3 times bx plus c. This is all over x plus 3 times x squared plus 9. So here's my linear factor. Here's that quadratic factor. Again, equal fractions with the same denominator. implies the numerators are equal. Okay, again, we're going to try taking cases. And my favorite thing to do, well, I might do this one a little different. Now let's just take cases. X is 0. We get 18. A times 9 plus 3 times C, really. Oh, we get 18 is 9A plus 3C. If I divide both sides by 3, we get 6 equals 3A plus C. Or we can say 3A plus C equals 6. Okay. So we get an equation. Let's now let x be 1. Well, you know what we could try is the approach that I started with talking about. Let's do that. I'm going to do a little algebra here. I'm going to share with you guys a nice, interesting technique. Don't know if you learned this in pre-calculus. But if you haven't, you could continue to take cases and generate equations here. And that might be okay. But notice if I use a little algebra here, we're going to get ax squared plus 9a. Now by FOIL, multiply the first term. So all I did was distribute right in here. Now I'm going to multiply. I'm going to use FOIL now. On the right side. First terms, I'll get bx squared, outer term, cx, inner term, 3bx. And then the last term, 3c. Okay. Okay, I'm going to gather all my x squared terms together. This term and this term. I'm going to gather all the x terms together. Then I'm going to leave my constants there at the end together. Constants. Okay. So I have ax squared plus bx squared plus cx plus 3bx plus 9a plus 3c. Since I have all these x squared terms together and I have the x terms together and I have my constants, I'm going to factor, ladies and gentlemen. So that means I have a plus b, factoring out the x squared. I'm going to factor out the x, c plus 3b, and then I have the constants 9a plus 3c. I want you to see something interesting here. Okay. What am I really looking at? What does this mean? You have an equation. And so I can write my 18 on the left this way. Since there's no x squared term on the left, there's no x term on the left, only an 18 on the left. I can write my left side with 0 coefficients wherever there's terms that are missing. And I just have that constant 18. Now, what does that mean? That means a few things. That means that the numbers in front here, the x squared, 0, for example. If I can get a highlighter, 0 is the same as a plus b. I know there's no x squared term on the left side. Well, that means use the 0 coefficient. That means a plus b is 0. The same thing is happening over here. There's no x term on the left. There was just a constant. So what this implies is the equation c plus 3b is also 0. And you may notice this equation in gray, the constants, we already wrote down as 18 is 9a plus 3c. Dividing both sides by 3, you end up getting 6 equals 3a plus c. And I'm going to use this in purple just to kind of share that with you guys, that the 18 is the 9a plus 3c. Those are the constants. I got this constant number 18 on the left. It's equal to my constants on the right, which is 9a plus 3c. So, like we said, that equation reduces to what you already know. And you might say, where did we get this one? Well, we got this one from when we took cases here. 6 is 3a plus c. Yeah, 3a plus c is 6. Now, we're going to use this system here to try to find a, b, and c. All right. The first equation, we can say this means a is the same as minus b. So this is from the first equation, solving for a. I can plug this in the third equation. A is minus b. I can put a negative b here. So that means I have 6 equal to negative 3b plus c. So solving the first equation for a and plugging that into or substituting the a value into the third equation. First, second, third. We already know that 0 is the same as 3b plus c from the second equation. So the second equation, we just didn't change at all. So how that's helpful for us is that by adding these two over here, using that addition method, add your left sides, set it equal to the right sides. This means we end up getting a 6 is actually 2c, or 6 over 2 is c. C is the value of 3. And this is a really good thing to have. So C is 3. Because C is 3, I can go back to one of these equations here. Doesn't matter which equation I go back to. I can go to any equation here. So since C is 3 now, if I go back and replace this C in the third equation with 3, notice I end up getting 6 is 3a plus 3. Subtracting 3 from both sides, we end up getting as 3 equals 3a, which means a is the value 1. So we get a is 1 here. Since a is 1, I can go back to this first equation. A is the value 1. I can plug that in. So that means 1 plus b is 0, or b is negative 1. We now have all our constants. A is 1. I'm going to write it down here. B is negative 1. C is 3. One, negative 1, and 3. 1, negative 1, 3. So I prefer the second approach, in all honesty. I think it's a lot easier than taking cases. But if we're looking at linear factors or that first quadratic, linear factors are fine to take cases, but I actually prefer this approach. What this means as a final answer is that 18 over x plus 3 times x squared plus 9 will equal 1 over x plus 3 plus a negative x plus 3 over x squared plus 9. So let's take a look at this portion here. I can factor out a negative 1. So if I factor out a negative 1 here for that first leading term, because it's negative x, you got to put x minus 3 there. Now, I'm looking at what's happening here. This is what I'm saying. Factor out that negative 1. That means the first term is the same. I can put minus x minus 3 over x squared plus 9. There you go. So the second approach, without taking cases, when it comes to these quadratic factors I always, starting with case 3, I don't really take cases. So, as you guys can see, you don't have to. You could go with this algebraic approach instead, which I think is a lot better. Anyway. Okay. Next example, you have a linear factor. And now you have a quadratic factor. And that quadratic factor is not factorable. All right, so this will equal, if I write it down, for the first linear factor, we just put the constant a over x minus 1. So there's our first linear factor. But now we have plus bx plus c for the quadratic factor. We got to find the coefficients a, b, and c. So the left side is equal to, we're going to do our arithmetic. In other words, we cross multiplied and obtained the sum, essentially. So here's your denominator. Same denominator, equal fractions implies the numerators must be equal. So this is what this means. The numerators have to be the same. It means 3x squared minus 4x plus 5 is equal to a x squared plus 1 plus x minus 1 bx plus c. So we're going to use this equation, but I'm going to be a little bit strategic because I like something I see here. Something that stands out at me. I know I just got through saying I don't like to take cases. Well, I might just take a case only for the first one. This is nice because if I let x be 1 everywhere, I can zero out this term. So that means 3 times 1 squared minus 4 times 1 plus 5 will be a times 1 squared plus 1. This will give me the value of a right off the bat, and I like that. So I'll only take a case for the first one. In this case, x is 1, and then we'll use the algebra. Order of operation on the left, and that gives me a 2a. So it looks like I get 4 equal to 2a, or a being the value 2. This is going to be very helpful to us. So I'll start off by taking that first case, I guess. Let me double check my work. Okay. Now, let's do the algebra now. Distribute here and FOIL over here. That's still equal to everything you see up here. So now we'll do our algebra. Let me add a page. Okay. So let's do some algebra. Down here, well, we're going to say this is going to be equal to ax squared plus a. Now by FOIL, we just distributed for the first one. Distributed here. Going to use FOIL over here. Let's now do our FOIL. First term will be bx squared. Outer term plus cx. Inner term minus bx. Last term minus c. Couple of x squared terms here. An x term and an x term, and then we have our constants. So this means we have a plus b times x squared plus, factor out the x, and then you're left with this a minus c. Those are the constant terms here. So let's see if we can see everything here. X squared. There's the x. And now I have my constants down here. Now, remember what exactly that means. Okay? What that means is I'll just write it down. U3x squared minus 4x plus 5 is equal to this. Compare the x squared terms. Compare the x terms. Compare the constants. What this says is that 3, right in here, 3 must be the same as a plus b. That also means negative 4 has to be c minus b. And then finally, 5 has to be a minus c. So this is what this information gives me right off the bat. Like that. Don't forget, though, a is 2. We already solved for a. So this is going to be extremely helpful to us. So that first case did help us out. Now, if a is 2, take a look at our equations. We got the first, the second, and the third. A is the number 2. What that gives us is 3 equals 2 plus b, or b will be 3 minus 2, which means b equals 1. So we have the value for b. We just need c. Now, we could use any equation. If I look at the third equation and let a be 2, that gives us 5 equal to 2 minus c, or 5 minus 2 is minus c. 3 is negative c, or it means c will be negative 3. A is 2, B is 1, C is negative 3. A is 2, B is 1, C is negative 3. 2, 1, negative 3. So Let's put this together here. Three x squared minus 5x plus 5 over x minus 1, x squared plus 1 will equal 2 over x minus 1 plus 1x minus 3 over x squared plus 1. And that 1x is just an x. Okay. This is how we handle quadratic factors.